minutes as people join. So just bear with us for 2 minutes and we'll get started. Okay, so let's get started. It's my pleasure to introduce Kevin Wang. Kevin is one of our experts in data replication, big data replication on Hadoop or cloud. And the webinar is going to be recorded. You will get a link to the recording after the webinar, and we will also share the slides. If you have any questions, please use the chat room, and I will be monitoring the questions throughout the webinar. Kevin, please go ahead and get started.
Thank you. My name is Kevin, and good morning, good evening, wherever you are. Today, I'll be talking to you about IBM Big Replicate. What is it, and what kind of problem does it solve, and benefits and features of why this offering from IBM is so exciting, and also talk about some of the technical aspects of this product offering. And we end with some of the common use cases that enterprises uses Big Replicate for, and we'll also have like Anna alluded, have a question and answer. We'll leave some time at the end for those. Okay, with that, let me just go ahead and get started. Here is just a quick view of the agenda. Like I said, I'll introduce to you what this IBM Big Replicate is all about, and I'll go into a little technical details about its architecture and how it technically resolves these challenges when it comes to enterprise data replication. And I'll talk about some of the common use cases associated with Big Replicate. And how enterprise today and maybe in the futures, and I show you how flexible Big Replicate is, that there's just potentially so many different use cases that you can use it for. And then again, we will have some time at the end for question and answers. All right, so what is IBM Big Replicate? IBM Big Replicate is actually powered by WinDisco's patented replication engine, and what it does is give you a virtual namespace across all your enterprise storage infrastructure, and it is the only wide area network active transactional replication technology in the marketplace that delivers continuous availability, streaming backup, uninterrupted migration, hybrid cloud, and burst to cloud exceeding the most demanding enterprise SLs out there across any combination, and we do this with any combination of Hadoop distributions and cloud storage. Whether that's IBM Biginsights or Cloudera, SCDH, Hortonworks HDP, MI Power, so on and so forth, or you could have a mix of on-premise distributions and also on the other end, you have data stored in either Amazon S3 or IBM object storage. And for that matter, that includes any of the other cloud providers as well. So, so in a nutshell, IBM Big Replicate allows you to replicate data across any of these storage infrastructures across any distance, and with virtually zero downtime. And on top of that, it is totally non-invasive. There's no need to modify any source code, and you can easily turn it on and off. Now let's go into more details. What it's at the core is a proxy server or more deployed to each cluster that intercepts all write requests to the underlying file infrastructure. So client apps connects to Fusion, or this is what the WinDisco Fusion is called underneath the IBM Big Replicate umbrella. That Fusion is the name that which is the core function for as a proxy server to intercept write requests from client applications. And like I said before, it provides a single virtual namespace across any clusters at any distance apart, whether that's on-premise or on the cloud. And really allows enterprises to break down that information silos across, their different data centers made across different geos, and whether it's enterprise data warehouse or just local file storage or some regional data centers. All of those data could be replicated in near real time. So let's talk about the benefits associated with IBM Big Replicate. First of all, its continuous availability and performance. With the explosion of data, many multinational companies have data centers, across the globe, and data replication become a challenge because whether it's Hadoop or any other storage options. With Big Replicate, it allows you to replicate data as it's ingested. So it doesn't have to wait for the file to actually written to the underlying file system at the source data center before it can be replicated. So unlike some of the other common replication solutions with Hadoop specifically, such as this CP, which requires you to schedule backups or this replication backups outside normal business hours, because this CP runs MapReduce jobs underneath the table, and which takes resources, computing resources, and that's why normally enterprises schedule these replication jobs outside business hours to do this. So it's essentially a batch fashion that data are delayed getting to their target destination. And DCP solutions can also have the potential to lose data since the last backup due to any type of failure. MapReduce job could run into errors, and then you get into problems with data not being synced up between the source and the target clusters. And with IBM Big Replicate, it doesn't have that issue. Data are replicated as it's ingested. It doesn't have to wait for the file to be completely written to the file system. It can replicate at a sub-block level, and again, enabling that a near real-time replication across any distance. Yet it can be also installed on live clusters without downtime. Again, ensuring that continuous availability for your clusters, and again supports different distributions and multiple versions of the same distribution. So, for example, you could have IBM Biginsights 4.1, 4.2 mixed in the replication that participates in the replication. You can even mix that with some of the other distributions from other vendors, such as Cloudera and the HortonWorks. And those clusters can either be on-premise or on the cloud. So let's say you have 3 clusters across 3 data centers that's participating in the replication scheme. You can also have a 4th replication site, which is on the cloud, whether that's on the IBM cloud or some other cloud vendors. Another big benefit of Big Replicate is full use of compute resources, because the real-time active transactional replication, all clusters at all locations are fully readable and writable, and there's no waste on these read-only backup clusters that many enterprises are having today, because they have these backup clusters to to have data replicated to them on the batch intervals, and only want to use them when some disaster happens. But with BigReplicate, those resources on the back clusters can be fully utilized without being sitting idle. And because of that, these backup clusters can be used to scale up deployments. Say you have your data grows very rapidly. You have more applications deployed, so the workload grows, and now these backup clusters can be fully utilized without spending more money on additional hardware or deploying, growing the let's say the primary cluster. Another big thing is multi-data center ingest. Like I mentioned before, multinational companies have data centers across the globe. So you could have a data center in America, in the US, or one in Europe, or one in Asia. And all these data centers ingest data, and maybe they're for different purposes. One data center could be ingesting, call center logs, another one social media. The third one, is is used for some other purposes that ingest certain data. And with BigReplicate, all these data centers can be kept in sync, and eliminates that delay. When people today, a lot of times they develop these complex data pipelines for data to be moved around to be analyzed. So with BigReplicate, all these data can appear at all participants of the replication, and they can be readable and writable at the same time. Selective replication with global access is another benefit of BigReplicate, because sometimes due to regional regulatory requirements, some sensitive data has to stay in certain region. So with BigReplicate, it allows you to select what data are to be replicated, what data you do not want to be replicated, so that you keep the sensitive data in the region where it belongs to comply with wherever the local regulation is. Another huge benefit with BigReplicate is data protection. With backup or replication solutions such as DCPs, it needs every data node in every cluster in every data center to be able to communicate with each other, so to enable the transferring of data. However, with BigReplicate, it eliminates that need, and therefore it minimizes the attack surfaces. So today data security and privacy is a huge thing. Every day there are attacks happening around the world, and with IBM BigReplicate, you can have that active, near real-time data replication without the concern for a huge attack space. Flexible and future-proof. Like I said, because BigReplicate allows you to replicate between different distributions from different vendors or different versions of the same distribution, and also whether it's HDFS or any HDFS compatible file systems and cloud storage. There's no vendor lock-in with BigReplicate, and it allows you to do migrations to and from different versions, without any downtime. Hybrid cloud and cloud migration, as many of you aware, that this hybrid cloud and many people use cloud as the sort of the backup capacity in case the primary cluster gets overloaded because certain spike in workload. on the primary cluster, and then they sort of overflow to the cloud infrastructure, where it allows that elastic, where companies can leverage that elasticity associated with a cloud infrastructure, and BigReplicate allows you to replicate data such that in the case where you need that extra computing power, the data is there for you to process, just as if it's it's in your primary data center, which is on premise in other cases. Next, I'll talk a little bit about the architecture behind BigReplicate, namely how this patented WANDisco fusion server works. So there are really three key components in IBM BigReplicate, and I'll go into details of each of these components. So you have that fusion server. And also there's something called IHC server, or inter-Hadoop communication server. And there's also a component called Fusion Client that all three of these components deploy to each cluster, and we call them zones. So let's start with Fusion Server. Fusion Server is essentially the core piece of WANDisco Fusion. What it does is it intercepts file change or any kind of, essentially write operations from clients. On whether somebody wants to copy a file to a certain directory in the file system, or data is being streamed into the underlying storage system, whether it's HDFS or any of the HDFS compatible file system, the Fusion server deployed on that cluster will intercept those operations and coordinate those changes across clusters using a engine we call DConE, which stands for Distributed Coordination Engine. And I'll go into more details about how that DConE engine works. Normally, so one Fusion server is required per zone or per cluster. And obviously, you want to have two or more deployed for high availability and scalability purposes. And one note of caution here is that we don't want to deploy Fusion server on a data node because it can potentially cause unbalanced data in cluster. And this is the system also runs the Fusion UI, which is the web interface for administrating BigReplicate. Now let's talk about IHC server. IHC server, like I said, stands for Inter-Hadoop Communication Servers. And this component handles the actual traffic between zones, or between clusters. So when data is being replicated, the IHC server reads it from the local zone and stream it to the Fusion server on the remote zone. And that Fusion server then writes it to this local zone. So in that sense, all these writes are performed as local operations. There's no special cross-zone security required. And the reason to have a separate component, in this case IHC, is to isolate components that depend on HDFS distributions, and that's really what enables BigReplicate to work across different versions of the same distributions or different distributions across different vendors, or any combination of those. Again, like Fusion servers, at least one IHC server is required per zone or per cluster, but you do normally want to have two or more for high availability purposes. In the case of IHC server, three actually preferred for having a quorum consensus, which I'll talk about a little later of what this quorum consensus is about, and it really has really it is a part of the distributed coordination engine, or DConE engine. Fusion Client. Fusion Client is a set of jar files installed on each Hadoop client, such as mappers, reducers, and the gateway nodes. It's not a service or agent, so it can be deployed with stacks in Ambari or parcels, if you have Cloudera Manager, or you can just do manual RPM installation on each node. And it essentially tells applications to use Fusion classes for HDFS operations, specifically for write operations. So, so these classes redirect all requests through the Fusion server. Something to note here is it passes through reads. So in read operations, it simply passes through and doesn't do anything about it, because it's a read operation. But when it comes to write operations, it intercepts it and make that coordination with the remote clusters. So here's a diagram showing, how this architecture works. So in this diagram, we have two data centers and that are participating in a, let's say, an active scenario, and a user or an application on cluster 1 it initiates a write request, and that gets intercepted by the Fusion server on that cluster, which then coordinates that write request with the Fusion server on cluster 2. Once it gets the agreement, it writes that data to its local file system, whether it's HDFS or any of the other Hadoop HDFS compatible file system, such as EMC, Echelon, MapR, or S3. Once it writes, the IHC server reads that from the as it writes, the IHC server read that data and then replicate that to the or better word, stream it over to the remote cluster or second cluster to the Fusion server, which then write to the local storage infrastructure on that remote cluster. Here's essentially the same thing, except the one end of the participating cluster is on the cloud rather on the premise, which is very similar. So whether it's on the cloud or on premise, the write request goes to the Fusion server, then it gets coordinated with the other end. Once an agreement reaches, it writes to the local HDFS or any of these HDFS compatible file systems, and then stream that data over to the remote zone, whether that's cloud or, in this case, cloud or on-premise. So I pretty much explained, how this flow works in my previous charts. But again, here is just another view of this flow. So you can hear I'm showing multiple Fusion servers deployed per cluster. But again, these Fusion servers all participate in what I call a member in the coordination. So which I explain later on. This gets into how DConE works. But in a nutshell, the workflow works the same way. You have user sending the write request, then the Fusion server will intercept that request, coordinate that with the remote region zones, and then do the actual write on the local file system. Our server will read that and stream it over to the remote cluster, and the Big Replicate allows you to do this, whether it's active. That means any request, whether that's from data center 1 or data center 2, it goes both ways. So it's bidirectional. Again, this is a workflow for HDFS to and from HDFS scenario, which like I explained, this is how it flows. It goes to the second data center, coordinate that, writes to the local disk, and then the IH server would stream those data to the remote server, and then what gets written to that local system on the remote server. This one again shows, one of the participating member of cluster is actually Amazon S3, I'm sorry, AWS EMR, and it essentially works the same way. So I'm going to skip this. Now, I'm ready to talk about this coordination. So before I talk about that, I want to show you what is the architectural principles for behind Fusion or IBM Big Replicate. The architecture principle really is we want to ensure strict consistency of metadata with fast data ingest. So so it uses that coordination engine, which I'll explain, and then it allows data to be streamed in the background, and so that and not only that, like I mentioned, it doesn't have to wait for the file to be actually closed or to be fully written. It can transfer file in block or sub-block increments. And a small and large file transfer can happen in parallel. So here I have a little sort of animation showing this how this distributed coordination engine works. DConE essentially implements a distributed replication algorithm called Paxos. It is mathematically proven, and what it does, it essentially all participants in the replication scheme has to reach a majority quorum before a transaction or a write request can be written on all participants. So let's say we have 3 clusters in this case that participating in the replication scheme or membership. Cluster B, we have a write request. Let's call it transaction 170. So it generates a proposal to A and C, which then say, okay, we agree that this write can happen, and then it goes through. So in the case if a node goes down, let's say in this case cluster A goes down for any reason, whether it's network issue or some other issue that cause cluster A to go down. During the time when cluster A is down, cluster B and C continue to operate with a quorum, and in this case, let's say B now wants to write another request, issues transaction 171 and 172. C wants to write 172, and it continues just while cluster A is down. But now let's say services being started, network is being restored. Now A is back, but as it rejoins, what IBM Big Replicate does, or this DConE engine works, is puts this node in a safe mode until all transactions are caught up, and then they are, and then A is fully back in this quorum scheme, so that any new requests come in, now we are back in full operation. So in the case of disaster, let's say cluster A is completely offline. It's completely wiped out. There is no, bringing back service in the short amount of time. We can still do that, and allows that to happen when eventually A is rebuilt, and it will catch up with all the all the data, and have those data ready for queries, just like before it goes down. So it enables you to have this full resiliency across all participants, whether it's partial failure or some sort of a catastrophic failure. Again, this is another pictorial view showing how it works for the DConE engine, and it does this coordination, does the write, agrees, do the write, streams over, and then data are replicated across all zones. Now let's talk a little bit about the use cases, the common use cases associated with Big Replicate. Now, first one, disaster recovery. This with Big Replicate really takes disaster recovery to the ideal case, where you don't have to have sort of active standby, where either those these remote disaster recovery clusters are sitting idle, wasting computer resources. With Big Replicate, essentially you have zero downtime. If something catastrophic happens on your primary data, your cluster data center, the work can be transferred to the disaster recovery cluster with essentially zero downtime, because all the data are there already. And this is very important, because some of the industries that are under very strict regulatory compliance around disaster recovery, Big Replicate allows you to achieve that auditability. Migration is another big case, a big use case for Big Replicate, because like I said, company nowadays uses clouds. Many of them use the cloud as sort of the backup computing resources, and because data is actively replicated or near real time, those cloud computing resources have the same data available to them when the need comes. Or sometimes when companies migrate, all their on-premise clusters to a cloud infrastructure, IBM Big Replicate allows them to do just like that. You replicate the data over, and then you switch over the compute. Your workload continues on the new cloud infrastructure. Multiple ingest points is another big use case. Again, multinational companies have data centers across the globe, and each of these data centers may have a little different application running on them, whether that's fraud detections, or equity trade, whether it's something else that's run, and all these data centers can have data used for different applications, all available at the same time, which is huge, that you can ingest data, one type of data in one data center, and it's available everywhere else for you to query. And in the cases, many large organizations have multiple clusters for different purposes. You have production clusters, development QA clusters, and they may have different profiles. When I say different profiles, they may have different server configurations. Maybe the production cluster has the most beefy configuration when it comes to CPU cores, memory settings, memories, network capacity. Maybe the development and the QA clusters have that's built on a little less capable hardware. But the key point here is doesn't matter whether they have different hardware profile or not. They all have the same data available to them, so that when you do where a developer a new application or you're testing a new application, the same data on a production cluster is available on the development and test cluster. Again, this with BigReplicate, another use case is multi-zones. When you have different profile of applications running, so this allows you to have say on one cluster you're running SparkJob, which is very much memory intensive jobs, and with BigReplicate allows you to do that, so that the different profile of different applications can run on multiple different clusters, yet the data are available to all of them. Security isolation, like I said, with the selective replication capabilities of BigReplicate, you can choose to replicate some data, but not all the data, where you want to keep some of the sensitive data in the region where it belongs, due to the local regulatory requirement. So again, here's a little animation. Data lakes is another big one. So this is very important for an enterprise to have a 360-degree view of its customers, so that they can perform, they can correlate and get insights from those data. And BigReplicate allows them to do that. Not only do that, but in real time. And real-time analytics. Real-time analytics is becoming very, very popular because some of these data, what we sometimes refer to fast data, the value of those fast data expires very quickly. So you really have to gain insight on the spot and be able to react, or sometimes predict, and stop something bad from happening before it even happens. So, credit card fraud detection will be a perfect example here. It's no use if a credit card fraud is detected 24 hours later, because it had already happened, and now it becomes a recovery task, instead of if you can detect the fraud on the spot and be able to prevent it from a fraud charge being happen. And then that's where the fast data, the value of fast data comes in. And with BigReplicate, because we can ingest data as it comes in, we don't have to wait for file to complete. This can be done across multiple data centers and the land speed. Another big use case for BigReplicate is, again, not only can do HDFS, but it can replicate data between any combination of whether it's NFS mounted file system, local file system, or object storage on the cloud. BigReplicate allows you to replicate data between any of those combinations. So this pretty much concludes my presentation today. Anna, do we have any questions so far?
We don't have any questions right now. Are there any new questions? No, it doesn't look like we have questions, Kevin.
Okay. So with that, we'll conclude today's presentation, and I believe the recording will be made available soon. And if you have any questions or comments, feel free to reach out to me. Again,
we actually got a question. We actually got a question now.
Oh,
How is this different from AWS solutions?
How does this different? So AWS. So if I understand the question correctly, the question you're asking that how does BigReplicate different from AWS? AWS allows you to essentially import data or replicate data from a on-premise into AWS. The difference here is BigReplicate. So AWS makes it very easy for you to import data into AWS, but makes it really hard if you want to get data out of AWS. What IBM Big Replicate allows you to do is that bi-directional capabilities.
Okay, thank you.
I hope that answers the question.
Yes, he says thank you.
Okay.
Okay, so thank you everyone. Thank you, Kevin, for your presentation today, and thank you everyone that joined. You will receive a link to the recording and also a copy of the slides. Thank you.
Thank you so much.